we've graphed a lot of stuff this year. We've done like, let's see, parabolas, square root functions, cubics. What am I forgetting? Probably more stuff. I'm not even thinking about them. So these today are going to be called reciprocal functions. So here's how this works. I'm going to write this a little bit small because I want to show you both ways this can show up. Again, I'm not people's friend at the end of May if they're not doing stuff right. I'm just saying. Just saying. Always got. I'm just saying. So okay, when you see these equations, you might see y equals. You might see f of x. That's function notation. These are functions. So they both mean the same thing. So let's take a peek at what this is going to look like. So, since it's got 1 over x, that's what we're typing in y equals. 1 divided by x. And graph that thing. So you're like, okay, what is this craziness? So this is a graph that has things called branches on it. There's 2 of them. One of them runs right here along the x-axis and then curves and hugs along the y. And the other one, there's where the reciprocal part comes from, starts along the y-axis and then curves and goes along the x. So when we're graphing these, a couple of things to note. This is called a hyperbola, not hyperbola, even though that would be appropriate in here. Hyperbola, and your domain and range. Now here's where we're going to have to put a couple of pieces together here. Your domain is going to typically be all reals not equal to 0. I'll explain why the not equal to 0 here in a minute. Because remember, domain has to do with x values. Our range, typically for a reciprocal function, are y values. Will also be all reals not equal to 0. So for this to be true, because when we were looking at the graph, I mean, it kind of just, oops, let me keep that up here. It kind of just keeps going forever. So if you were to graph it, it kind of looks like this. Let me do it in a different color here. So it kind of hugs here, curves out, and then hugs here. It doesn't go past it. It just is really close. And it does the same thing down here in quadrant number 3. So why does it do that? It does because there are asymptotes. Now we remember those, hopefully. Those are those dotted do not cross lines that we get into. So you're going to have a vertical one at x equals 0. So if you have an asymptote there, you can't have a value there. That's why it's all reals not equal to 0. And you also have a horizontal asymptote. It's called y equals 0, which is why your range is all reals except 0. So in other words, your graph goes forever up, down, left, right, except where these asymptotes are. And there's a real easy way to figure out where they're going to be. That's really the only thing we have to think about with this. Yes, sir?
Why isn't it like a right angle? Why does it curve instead of 6? That's how it works.
Because the 1 over x, if you think about a fraction, fractions keep getting smaller and smaller, but they don't ever get exactly to like 0 or something, but it can get really close. I'll show you, because as that number changes too, it'll start stretching further and further away from the middle as we do that. But we'll see. That's a good question and something that we will discuss. So, okay. When we look at a little bigger form of this, because there's some stuff that's going to happen. So, okay, here we go. Lots of variables coming, but we're going to define all of them very well. Okay, when we start to move this graph, there's 3 ways it can change. We're going to label all of them and then discuss what they each do. So we're going to start with H, this value right here. H is going to be your horizontal, your side-to-side shift. So this H, when it's positive, when it's plus, it shifts left. And when it's minus, it shifts right. Kind of like before when we did square root functions. Now, this was a while ago, I know. But when we did those, when we did parabolas, this was always my left and right. Still is. This was my up and down, and that's going to be true as well. Because K is our vertical, our up and down shift. If it's plus, it goes up. If it's minus, it goes down. So if you want to, it may not be a terrible idea to kind of make yourself a quick little note here and be like, hey, this is my left and right, kind of put my signs with it. And this is my up and down, and put my signs with it. Because then when you're going to graph stuff before you even look at the calculator, you're kind of going to know what everything looks like, which is always an advantage. And, as Kira mentioned here, getting a little bit ahead of us, but there's nothing wrong with that. This A value also is going to have a purpose. If it's negative, our graph is reflected. We've also used the word flipped in here. It's flipped across the x-axis. So what does that mean? That means, yeah, if the A value is negative, this would be up here, and this one would be down here. And we're going to see that. But A has a second job, too. A also represents a stretch if it's getting bigger, which means it's going to be getting further away from the asymptotes. Or if it's a fraction, if it's between 0 and 1. It gets compressed. It gets smashed in even tighter, like you're smashing a can or something like that. Now, we don't see the A value stuff mess with things as often as these two do, which is why it's important and why we're going to do most of our discussion about what H and K is doing when it comes to this stuff. So reminder again, vertical, x equals whatever our H value is. Horizontal, and again, I know it's crazy without even numbers yet. I get that. Y is going to be our K. So for now, we are going to bypass the writing of these with just a bunch of words. I want to get right to the equations because that's where we're going to get our best work done. So we are going to flip over to 12. And we're going to actually start messing with these things and seeing how this works. So let's see what we got here. Okay, graph the function, identify the domain, the range, and the asymptotes. Okay. Before we even start, here's what we're going to ponder with these. The first thing I always want you to notice, and I'm going to put the regular function up here for a sec. I'm going to use 1 because that's normally our normal here. Okay. First thing I notice right away on number 4. There's no number down here with x. It's just x. Okay? So here, my h value is 0. Which means my vertical asymptote is at 0 because x equals h. If there's nothing down here, we put 0. We don't put none. We also know, before we ever start, if there's a number at the end, whether it's positive or negative, we know that's our k value. In this case, it's -2. K value, the number on the end, is always your horizontal asymptote. So again, I haven't graphed anything yet, but I still can fill in everything down here because your domain is always all reals except your asymptote. Because there would have to be a number down here, a plus or a minus number with my x for there to be an h. Yeah, then I'd have an h value, but if I don't see one there, it's just 0. It would be positive 8, but we'll get to that in a minute. We'll explain why that is. And if you don't like having to write out all reals like that, if you remember back, we talked about the double-barred R that you can use to do, say, the exact same thing. So we can get that filled in. We can do the same thing for our range with our horizontal asymptote. All reals not equal to -2. What that allows me to do is on my graph, I can put my vertical asymptote in. And if you want colors, I got them in the back. I can put my horizontal asymptote in. And now, if I want to make sure that I'm accurate as far as my graph goes, I can go ahead, except I got to type it in right, 1 divided by x minus 2. So you're like, okay, so how do I know that I did this right? A couple of ways. Number 1, you notice that the horizontal asymptote moved down, so we're feeling good. It looks like it's hugging the y-axis here. That's good as well. But there's another thing you can check. If you look at the table, second graph, you will always see an error message where your vertical asymptote is. So here I know for sure I did that right. There's not something on the calculator to help me with the horizontal on that, but I can get that checked. And what I always tell people is this. For an accurate graph, find your error message, find your vertical asymptote, and graph 2 points on each side of it. So in other words, if I go to -1, it says go to -3, so I'll do that. And -2 would be -2.5. Those kind of tell me where my curve is. So it kind of just hugs the axis till you get to your 2 points that you plot. And I'm going to do the same thing on the other side. So here's my 0. If I go to the other side, it says 1, -1, and 2, -1.5. So these are really, really close to my asymptotes. That will change. Yeah. Yeah, because if I go to all whole numbers, sometimes I won't get a second one. So I usually just use the first two, even if I got to use a decimal and just kind of wing it. Okay? So that is about as straightforward as most of these are going to get. Now, let's flip the script. This one I look, it's the one after this I'll start asking for help. This time I notice, why did I take that off? Let's flip this back. This time I got an H value. But here's the thing. Your H value here is -3. Here's why. Notice your formula. This says x minus h, or the way I like to look at it, x and then take the opposite of what you see here. What's the opposite of 3? It's -3 is the actual h value. You're like, wait, how is that possible? That seems kind of messed up and weird. Because let's look at it this way. If this is x minus h, okay, if h is -3, what happens when you minus a negative? You add. X plus 3, that's what it's supposed to be. So that's why whatever you see here, you've got to think the opposite. So if you see +3, the h is actually -3. That's kind of weird. Okay. So then that's my vertical asymptote. X is -3. And my domain is all reals not equal to -3. So all these things go together with each other. But this time, I don't see any plus or minus number at the end. So, like, if you don't see one, it's 0. So my k value is 0. It's not none. So my horizontal asymptote, so you're like, wait, so that's always the vertical asymptote and that's the horizontal. Basically, yes. That's true. So we get that in. And again, by putting those, writing your asymptotes in before you graph it, now you kind of know, am I on the right track or not? Because when I go to type this in, I got to show you one other thing here that we got to make sure we do. If you see pluses or minuses in your denominator, when you go to graph them, you've got to use parentheses. Otherwise, you're going to get a different graph. I'm telling you, it's true. So I look and I hit graph, and I'm like, all right, let's see. Yep. My vertical asymptote moved left. That's good. Hugging the axis. Yep, just like that. If you ever graph it and it doesn't look like your asymptotes are in the right place, you probably just typed it in the calculator wrong. So if I pull up my chart, okay, there's my -3. That's good. Now let's put the points in. So -4, -1, -5, -0.5. Again, a lot of these, we're going to see a different one in a minute here. -2, 1, -1.5. Get those in there. And we're in business. So, I'm going to go past 6 for a minute because I want you to see all the things at once. We're going to go to 7. So 7, ooh. Okay. What's my vertical asymptote on number 7? Kind of use number 5 to help you. I think I heard it. +2. Yep. Just take the opposite. I'll stop doing the H and K thing over here after this because I think we're going to have this locked in here pretty soon. What's my K value? What's my horizontal asymptote? -2. Oh boy. So again, we have hints already on what our graph should look like when we go to the calculator. So just for fun, even though I know better, what happens if I type this in my calculator and I don't put parentheses at all? Yeah, that doesn't look right. Like, this looks like maybe, but that's like back on the axis. That's weird. That's dumb. Let me look at this. My error's at 0. What the? My calculator's broken. No, it's not. Okay. We've got to make sure those parentheses get in. That should make life look better here. Let's see. That's better. We're over here to the right. We're down. We should see. That's the vertical we wanted to see at 2. Now we're in business. So let's see here. 1, -5. 1, 2, 3, 4, 5. We're finally getting some space here. 0, 1, 2, 3.5. So notice this time our curve gets a lot further away from the asymptote because my A value got bigger. When the A value gets bigger, we get further away from the asymptote. This is kind of another little helpful tidbit here. 3, 4, -0.5. So we can see things a little bit easier. Okay. I think one more for now. Yeah, one more for now is going to be about our limit. Let's do 9 because we have not seen a negative A value yet. So let's make sure we do that. We're just going right down the edge here. It's odd day. Okay. Let's cut to the chase. What's my vertical asymptote going to be on 9? 5. Flip my sign on my one that's with X. All reals not equal to 5. Okay. What about my horizontal? 3. It's always that plus or minus number on the end. So let's see here. What other fun stuff can we have in store? Again, make sure your parentheses are there. I should be doing a good job of putting that on here. Let's get these on here first. 1, 2, 3, 4, 5. And 1, 2, 3. All right, let's see if this looks right. Now, you may wonder, maybe you don't, I don't know. Some of you may wonder, like, wait, why does it look like it stops, like here in the middle of nowhere? It's not stopping. It's just that it is so close to the asymptote at that point that you don't see it blended into the graph. But no, it does not stop there. It does keep going. So that's why I'm going to find out who's just like a screen copier when we get to the quiz down the road here. So we're looking good. We're above. We're to the right. Okay. There's that error message that I'm looking for at 5. Bingo. So let's see here. 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3.5. Get my branch in. 6. 1, 2, 3, 4, 5, 6. 1, 2. 1, 2, 3, 4, 5, 6, 7. 1, 2.5. And here's the last thing I want you to notice. I'm just going to pull this down so you can see it. Notice, we talked about this at the beginning. We hadn't gotten to see it yet. If your A value is negative, instead of your branches being in quadrants 1 and 3, okay, upper right and lower left, they flipped. Upper left, lower right. That's what the A will do every time. It'll flip those. So it doesn't mean you've done something wrong. It just means your A value caused you to do that reflection. Okay? That's it. That's it. It's not bad graphing. It's not bad stuff. So, let me flip this around. Hang on a minute. Yep. Okay. Can I sneak this up here? Well, that's going to be good enough. Okay. Page 1 and 2. Skip 1 through 6. So if you want to know which ones am I doing, you're doing 7 to 14. So I'll even write that. Do 7 to 14 in your brand new, lovely practice packet. So that's the game plan.